Let's talk Gibbs-free energy today. It's a hot topic.
I don't know what that is.
Yep,
Are we
I
just
know.
writing notes today?
Yep.
Alright. Does that mean I can sleep?
Nope.
Why not?
It's on
'Cause you can't.
Bravo.
It is, but y'all don't watch it.
I just don't know how to find it at all.
It's not hard.
That video YouTube.
Type in the date. May 11th, 2010, chemistry. It'll pop up.
Nuh-uh. Oh my God. We're doing it?
I just typed in your name
Going
already.
from after school? Oh no, the weekend before. After 11. Oh. It was before 2017 chemistry.
Wait, I go 10.
Oh, so you said chemistry? Chemistry?
Yeah.
I looked it up this morning before.
How can we
Did you find it?
The toilets and nothing was nothing like this.
give reaction? There she is, right there.
Right there.
All right. How can we decide if a reaction will occur? Now, why do y'all have to say yes?
Because it's
Not a good answer. Now, way back, since I know y'all don't know the answer to this, about, all right, answer the question. How can we determine if a reaction will occur?
temperature.
So,
That's
We don't know.
no, it's not. Number one is an old question. I'm expecting an answer from several months back.
Oh. I thought you were going to say Sarah Ellie.
I wasn't. I was thinking several months back. Now, Sarah Ellie might know the answer. I don't know. She may not remember either. I'm hoping someone else will know the answer too. And not that you've pinned all your hopes and dreams on Sarah Ellie yelling out the answer.
Why not?
Anybody know?
No.
What's the question?
It's still written on the board. It hasn't changed.
Is it when something new is created?
Huh?
Is it when something new is created?
No. How can we determine if a reaction will occur? So if they ask you this on the exam, I suggest you guess.
If it changes color.
How will you know if it's going to change colors?
Chemical physical change.
How will you know if the equation is going to occur?
That's the like
About the surface.
Oh, the
surface
different
of the
things that happen
atmosphere.
whenever you mix them up.
How will you know if they're going to happen?
If
If
temperature
we guess,
change,
if
if you
we
see
guess.
temperature change in color, no? Is that
reaction.
what you're talking about?
No, those are the indications that a reaction, that you have a chemical reaction, yes. Y'all are trying to tell me that bubbles are a gas or light. Those are the 5 indicators of a chemical reaction, yes. All of those things are an indication of a chemical reaction. But I'm asking you how you would know if you mix this and you mix this, that the reaction is going to occur at all. Like if I put nickel in water, it's just going to sit at the bottom of the beaker. Or if I put sodium in water, it's going to explode. How do I know the reaction is going to occur at all?
Is that
What did we learn that might help us figure out if a reaction will or will not occur?
chemistry? Change.
Extensive or?
No.
Who was that?
Just tell
That would be
us.
Jalen.
It's hard.
I tried to tell you, a genius over here.
Why would you listen
Well, no,
to
just tell us.
Open her mouth.
Yes.
Just tell us.
Activation. That's what I was gonna say.
Back about, I don't know, week 6 or 7, we talked about the activity series. And we had some little arrows that had water is a liquid. And we had another little arrow that had water as a gas.
Isn't that the thing where we had to look in the back? Yeah.
And we had an acid.
Yeah, I don't remember.
And then we had oxygen.
Oh, wait.
And we had to figure out if it fell in a little range. And if it did, then the reaction occurred.
Yeah.
And if it didn't fall in the little range, then we wrote no reaction. You remember doing that?
Yeah, that was
Okay.
the window.
That's out the window, I'm sure. But that's one way we use to figure out if a reaction would occur or not occur.
Let her go the second.
Okay? Now, the second way that we can figure out if a reaction will occur is to use Gibbs free energy, which is what we're going to use today. And that's going to go with enthalpy and entropy that we're getting ready to review. Okay? Now, this is where those of us who don't study are really, really, really going to hate this topic, because each of them have positive and negative signs. And there are a total of 6 positive and negative signs that we've got to talk about today. Okay? No, just 6, not 60. I'm not nuts. All right? So, if we review what we did yesterday, all right, Gibbs free energy is made of 2 parts. So, everybody with me? All right, so let's review first. Yesterday, we talked about enthalpy. And this is all part of Gibbs. All of this is going into Gibbs. All right, we said enthalpy was heat content, right? Somebody tell me its symbol. Triangle.
H.
Triangle H.
Oh, no, entropy is.
Triangle H. All right, so triangle H could be positive, which meant what? Meant it was endothermic. That's good. So the negative meant it was what? Okay. Now, endo meant that heat was what? Absorbed. And exo meant it was what? Released. Now, because I didn't want to overburden you yesterday, I did not add in another piece that I need to add in now. Now, when we talked about chemical equations, I did not add in thermochemical equations. So I need to do that, and this goes back to our phase change. So this is not hugely different. It's just another tiny little piece. So if you think back to the other day, when we wrote solid plus heat yields liquid, first of all, can you tell me what phase change that was?
Endo.
Okay.
It's endo, right?
I'm seriously moving out west to become an alpaca farmer.
And I'm about to-
Yes, it is endo. Y'all have not answered endo or exo wrong, but you did not answer the question I asked.
Oh.
I said, what phase change is this? So, what phase change? Solid to a liquid. Okay. There we go. So, melting and freezing are what I was looking for. So, solid changing to a liquid is melting. That's very good. All right, the next question I was going to ask y'all was, is this endo or exothermic? And it is endo. All right, so how did y'all know that this was endothermic?
I looked at this.
The heat is where? It's on the reactant side. All right, so does everybody remember that because the heat is on the reactant side, it equals endothermic. Everybody remember that from the other day. Okay, if you're sitting there going, what's she talking about? You need to remember that part. Now, we need to add this into a chemical equation. And I'm just going to make up some numbers. Okay, I'll look at my notes and see if I have any real ones in a minute, but I probably don't. So we're just going to make some up unless I decide to go get my Chem 2 book over there. All right, so N2 plus H2 goes to NH3 plus, I bet you I've got this on a worksheet, so I don't have to make up some jacked up number. Where would the sheet be with this so it's not jacked up? Nope, I think you're getting jacked up.
Oh, did we do that the other day?
Nah, I'm gonna go with 92. I have no idea.
said
What it is.
86. 86.
There you go. All right. Now, if I write this equation, and by the way, I have no idea what the number is. I just made it up. If I write this equation this way, all right, this is first of all called a thermochemical equation. Has a name. You should be able to look at that based on what you already know, and we've already talked about, and tell me if it's endo or exothermic. And tell me the sign of delta H based on what we know. Hyro, get off that phone, take your earbuds out. Put it up, put it in your pocket, put it in your hoodie pocket, I don't care. And take your earbuds all the way out. Pretend that you're interested in what's going on in class, even if you're really not. All right, so Rebecca, what would you tell me? Is it endo or exothermic? Okay, why would you say that? Because it's what? I can't hear you. How do you know it's releasing heat? Why do you say that? Shh. Where's it at? Where's the number at? It's on the what side? There you go. All right. So, Rebecca said that this is a product. So she said that it was exothermic, which is exactly right. So what does that tell us about delta H, Alicia? Is delta H positive or is delta H negative? What does it tell us about delta H? It's negative. This is why I said some of us were going to hate this topic, because there's so many positive and negative signs, okay? And we're only talking about, at the moment, delta H. We got to go back and do entropy from yesterday. Everybody with me? So if the number or the heat is a reactant, it's endothermic, right? If the number or the heat is a product, it's what? Exothermic. Are y'all with me, or is it just Gabriel and Sarah Ellie who are nodding at me? Hemma's nodding too. Are you with me, Hemma, or no? Okay, I got like 3 people nodding. Betsy Bay every now and then makes a head movement, and I think she's with me. All right, the rest of y'all, I've got nothing. Trent smiles periodically, but I don't know if it's at my jokes or he's with me. All right. Now, entropy. We did yesterday. We're getting ready to go over your worksheet.
She said go back.
Who said go back? Thelma said go back.
Entropy is that's an S, right?
That's delta S. We're going there in a minute.
We didn't do that.
We did the worksheet yesterday.
No.
We didn't go over it.
Oh, it was a solid.
Mhm.
Yeah, it's all good. About to say, hold up now.
We didn't go over it. Y'all were working on it. You were supposed to finish your homework.
I did.
Good. We're going to go over it.
I finished it.
That's fabulous. We're still going to go over it.
You're gonna grade it right.
Hmm.
We're gonna grade it right.
Am I going to grade it? No.
Get that grade. So this is
Okay.
right.
Okay.
Yes, you can go.
So, entropy. What did we say entropy was yesterday? That's a symbol. I'll write that in a second. All right. Just like we said enthalpy was heat content, what did we say entropy was? Disorder. All right. Entropy is disorder. And its symbol you said was delta S. All right. So, I know. I told you we were reviewing. Doesn't it say review up here?
Man, I wish I was that.
Oh.
Yeah.
So I don't need to write this down, right?
It's your nose.
Can I fly here first? I'll pop it.
I'm still writing.
I so wish you would.
What is it?
He's going to buy my first alpaca.
How much?
Yeah, it's your present.
Yeah, when's your birthday?
Buy it for Mother's Day. I'm going to need it sooner than I thought I was. All right. Delta S is positive when disorder increases. All right. When disorder increases, delta S is positive. Put that phone up over there. Delta S is negative when disorder decreases. Now, just to review, since Jennifer was a little fuzzy on why we were doing this. All right, out of the states that you worked with yesterday, who had the least entropy?
Yeah.
So,
Oh, you're solid.
This would be why we're reviewing, Jennifer. See the varied answers there? So solid. Who had the most entropy?
Yeah.
Gas.
Plasma.
Part of our curriculum. Now, liquid and aqueous are the two I wanted to review and make sure we were all on the same page. So, who has the most entropy, a liquid or aqueous? Aqueous, and then liquid is here. All right, so gas has the most, then aqueous, then liquid. So most, and then least. Okay, so we did a worksheet yesterday, but we've not had a chance to go over those answers. Some of you probably finished it. Some of you did some of it in class and didn't. So get out whatever parts you have so we can go over those parts and see how we did. A-Q-U-E-O-U-S. Got it.
This one was just-
Yeah, was it this?
Yes. we need that. Tim, were you here? There we go.
There's a water, can I get some water?
Yep.
No.
Were you here for the graphs? They look like this.
Yes. This for this sweater. What's this?
That's for Tim. Behind you. Same thing. You keep this one too, Tim. You know he keeps going back to sit down.
Whoa.
But I always just learn how to pull it.
Okay. All right. So if we look at the answers, let me find mine real quick so I'm not staring over somebody's poor shoulder. All right. Question 1. Oh, I could probably use yours then. All right. Number 1. What happened to entropy? Increase. 2. From liquid to solid is increased? Is decreased. You go from a liquid to a solid, it decreases, goes down. You go from being able to move all over the place to I'm in a fixed pattern. And number 3, decrease. They're all gases, but you go from having 4 moles to 2 moles. Think about it. They're all gases, Selma, right? You ever babysat kids before?
Oh.
You got 4 kids to drop into 2 kids. What happens to your disorder? It goes down. That's why it's decreased. No, I said you're babysitting and you have 4 kids and now you're only babysitting 2 kids. I didn't say you had 4. Huh? No, somebody's parent picked them up. Number 4, you've got a solid and you become aqueous. That's increase. All right. Number 5, solid to liquid. Increase. Number 6, solid to gas. Number 7, aqueous to a liquid. That's decrease. Number 8, gas or solid to gas. Increase. Now number 9, notice they're all gases again because there's 2 moles on the left and 2 moles on the right, so it stays the same. Number 10, aqueous to solid. Decrease. Number 11, increase. Number 12, that is what? Decrease. They're all solid, so you're counting your moles again. So you have 5 to 2, so that's decrease. Number 13, aqueous to liquid. Decrease. Number 14, no change. They're the same because you go 2 to 2 and they're all gases. And number 15, decrease. Everybody there? All right. Very good. All right. So now what are we going to do with these 2 things? All right.
No say.
Now we're going to talk about Gibbs free energy. All right. Gibbs free energy is symbolized by delta G. Okay. It predicts. if a reaction will occur. Okay, it's just another way to decide if a reaction will occur. High road. Pick your head up. All right, it predicts if a reaction will occur. Now, delta G can be negative. Delta G can be positive, or delta G can be 0. Now, 0 means it's at equilibrium. I will tell you, I will not give you that. Okay? Because we're not going to calculate it. Our part of the curriculum is only going to ask you about these top two, mainly because the state doesn't really want you to calculate. It just wants you to understand conceptually. And since we're really not going to calculate with delta G, you're not going to get delta G equals 0 if we're not calculating. Okay? So we're not going to worry about the bottom one. We're only going to focus on the top two.
But we have to know what the bottom is.
I'm just telling you it exists, largely because some of you will progress beyond me based on future career paths. All right, delta G, if it's negative, means the reaction is spontaneous, which means it will occur. For example, if you put sugar in water, what's going to happen to the sugar? It's spontaneous. It happens on its own. You cannot stop it. Now, delta G being positive means it is not spontaneous, which means it will not occur. Okay? So anything that's negative occurs. It's spontaneous. When you put those two compounds together, a reaction proceeds and it happens. But if it's positive, you can put those things together all day long and nothing will happen. It's a lot like putting nickel in water. When you put a nickel in water, what happens?
Nothing.
Absolutely nothing. It is a non-spontaneous reaction. Okay? Now, how do we decide if something is spontaneous or not spontaneous? Well, there's a reaction for that, or an equation. Delta G equals delta H minus T delta S. So, in order to figure this out, we have to use what two things? Well, what's delta H? Enthalpy. And what is delta S? Entropy. So, we use enthalpy and entropy to figure out if a reaction will occur. So that's why we had to know those two things. Okay? Now, this is where sometimes your math skill with positive and negative numbers hurts you. All right? We're going to try. I have confidence in y'all. Y'all can do this. This is not hard. It's not hard. Catch up with me and I'll pull some samples up. I just got to figure out where I start. All right, has everyone caught up with me? Can I take this down?
Yes.
All right. Here it goes. It's going away. All right. I don't think it would be there. What do you know? Got it there. I'll give you a moment to write that down. You will see these on a quiz next week, along with some equilibrium problems. And these will be in free response, not in multiple choice.
to say something.
I mean to say what?
What you mean by sign?
Positive or negative? Now, the only thing that'll be different on the quiz, other than that, is the quiz will also say endo or exo, increase or decrease, and I'm just abbreviating here, spawn or non-spawn. So there's actually 6 questions instead of only 5, or instead of just 3 questions. That's the only difference between this question and the quiz question.
Oh, yeah.
But I have it set up as 6 individual questions on the quiz next week, because it'll be on Monday, because we'll do the equilibrium parts tomorrow. All right, so when you look at this question, y'all are looking at that going, oh, it's crazy. I don't know how to do this. But if you think about it, we've done all the pieces except the delta G piece. So how do we figure out the heat piece? What do I have to do?
He doesn't look like.
Heat is where? There you go. So if heat is here, what do I know? It's exothermic. All right, so if I already know it's exothermic, I've got one of my 6 questions done. So I know it's exothermic. So this is where I told you the signs will drive some of you cuckoo. So if it's exothermic, it's what? It's negative. All right, now we have 2 of our 6 questions done. Are you with me so far? All right, so now we need to do the entropy that you practiced yesterday for homework. So look at your states. What can you tell me about your states? I'm a solid and I'm aqueous. So what can you tell me is happening? It's increasing. Now you've done 3 of your questions. So what does that mean delta S is? Positive or negative? It's positive. Woo, we got 4 of the 6 done. All right, now the new piece that goes with today. This is where I told you when you did our math skills. And before y'all all get all bent out of shape. Those of you who had calculus yesterday or Wednesday, Tuesday, whatever that test was, this is like pre-cal. This is like pre-algebra stuff. Okay, babes? This is not math 1. This is not math 2. This is not math 3. It's not pre-cal. It's not AFM. This is like pre-algebra. You're only plugging in some positive and negative signs and figuring out what sign this is. Okay, so you don't need heavy-duty math skills to do this. So, what sign did you guys just tell me delta H is? Minus. We don't even have to worry about temperature. What did you just tell me delta S is? All right. So in math class, when you multiply a negative and a positive, what do you get? These 2 things are adding together. So in math class, what happens when you add 2 negative signs together? So delta G has what sign? So is it spontaneous or non-spontaneous? I don't have the board. I can't go up unless I minimize it. It's spontaneous. Okay? So this reaction would occur. When you put potassium hydroxide in water, it will dissolve. Okay? There's no stopping it. You dump it in water, it's going to dissolve. You can start making it a little faster, but it's going to dissolve.
So if it's negative, it's spontaneous.
If it's negative, it is spontaneous. That is correct. Okay? Questions about how we did that? All right. Do another one. Everybody got what they want? Leandra says, let's try another one. All right. You want to see how far you can get?
No, let's try another one first.
Okay. Well, I'm going to. All right. So, you put my deltas over here. All right. So, if I set it up just like the quiz is set up, I'm going to ask you exo or endo. I'm going to ask you increasing or decreasing beside delta S. And I'm going to say spontaneous or non-spontaneous. because there are 6 questions, not just 3. So see how far you can get. See if you can do at least the first couple.
Wait, so if it's too positive and the negative, what do we do? Is this the negative? It's the negative, right? It's on.
What?
I asked you a question for the last time,
Uh-huh.
and it's too positive and negative.
Yeah.
So,
If we go to the last, hold on, here, these two, that positive and that negative cancel each other out. So that makes a 0 charge on this side and a 0 charge on that side. The charge on this side has to balance the charge on that side. So this is neutral and that's neutral. Okay.
How'd you get that for just age? I thought that's how you found it. Like, were you just told me it's higher? That's what I found. I know.
But you look at the heat of the temp product when I actually
hey, okay, I think I got it.
And it's the X of the negative for the H.
Okay, I'm gonna hit it next.
All right. Can we talk about what you came up with? All right. What'd you say about the heat, Trent? What do you think?
It's okay.
All right. Trent says exo. Where's the heat at? It's a product. So if it's a product, it has to be exo. Do we agree with him? You should. So that makes delta H what sign, Sarah Ellie? Negative is correct. All right. Everybody with Trent and Sarah Ellie on the first part. All right. So what can you tell me about the states, Brian? All right. We go from a liquid to a gas. So he said increases. Do we agree with him on that? All right. So what signs you put there, Destiny? Did you put positive or negative next to delta S? Very good. All right. Everybody with Destiny and Brian on those two. Yes? All right. So if we take our delta G equals delta H minus T delta S here. Delta G is what I'm solving for. What sign did delta H have? It was negative. Minus T delta S is what sign? Positive. So negative minus a positive. Again, we get a what when we multiply those? So when we add those, we get a what? So delta G is what sign? Negative, so it's what? All right. We okay? Let's try another one. All right, do that. Yeah. This is bad. All right. Who's going to tell me if it's endo or exo? Let me see. Who haven't I talked to? Hyro. Is it endo or exo? All right. How'd you know? You did not guess? Tell me how you know it was endo. Without Kevin telling you, because I know you know. Eric, how do you know it was endo?
Because it was on the reactive side.
Because he's on the reactive side. All right, so because heat is over here, we knew that it was endo. All right, so if it's endo, we knew the sign was what, Bryce? Okay, so delta H is positive this time. Everybody with Hyro and Bryce on positive. Yes? All right, Emma, what'd you say about our delta S? Is it increasing or is it decreasing this time? What do you think? They look the same to you. Okay, so what can you tell me about the states? The states are all what? They're all gases. All right, so what would you go to next if they're all gases? The coefficient. So how many moles do you have on this side? 3. Would you stop? Emma, how many do we have on this side? Do you know how Tevin got 3? Okay. So 2 plus 1 is 3 moles on this side. And it becomes how many moles on that side? How many? How do you get 3? 2. There's only a coefficient of 2 here, so it becomes 2 moles. So like the example I used a minute ago with Salma, you were babysitting 3 kids, and now you're only babysitting 2 kids. Does your entropy go up or down? What? Down. All right, so it's decreasing this time. So if it's decreasing, what sign does delta S have? It's negative. Okay, so now when I plug in my delta H and delta S, equals delta H minus T delta S. I've got what for delta H this time? Positive minus a negative. So what happens when I multiply a negative and a negative, Betsy Bay? I get a positive. So I got a positive. I'm adding a positive. So I get what kind of number this time? Anybody? A positive. So what did I find out this time, Jennifer? It's what?
Not spontaneous.
It is not spontaneous. Questions?
How did you get it to be a positive and a positive?
So-
That's what messes me up to get
Because you're
the delta
multiplying
G.
the negative with another negative.
So what now?
I'm telling that you get the negative and multiply with the subtraction sign. That's how you get positive.
Yes. Because this is a subtract sign right here. Okay? And that subtract sign multiplies that negative number. Okay? And because that's subtracting that negative, multiply, you get a positive, and those two numbers are gonna add.
So it always multiply with the delta.
Yes, yes, yes,
Oh, and then, okay.
yes. All right, last one. Salma wants one more. Just do the second one.
Do a second one.
Just do the second one. Okay? Same questions. Just do number 2. Last one.
We're not doing number 1?
No.
No.
It's because he has his earphones.
All right, can I do number 2 then?
That's me at home.
I've decided that's all teenagers. You're not unique.
I was.
All the time. It's not spontaneous. Oh. Yeah. Not spontaneous. That's what trips me out. So doing this.
Why would I need to?
Way to go, yeah. I'm skipping. She has some things.
Let's go ahead and do number
So
1.
she keeps track of where you are?
That's what she never calls. You know what it is? She always knows. She said it's for
I'm sorry.
Usually know where my kids are right now.
That was funny. With Jason Poe.
All right, can we talk about what you came up with?
That's one. That's a little bit too
No, it's not.
It's too fast? I don't have to irritate Slang. All right. So, what'd you come up with? Is it endo or is it exo?
Yeah, for you tripping.
Is what?
It's
Are you doing number 1 or number 2? We're all doing number 2.
Yeah, I'm at number 2.
Yeah, and she was talking about me.
Yeah.
I'm serious.
Get
I'm
on
at number 2.
Get on it. She's smoking her crack.
Number 2 has heat over here, so it's what? It's endo. So if it's endo, delta H is what? Positive. All right.
S is negative.
We go from being a gas to being a what? So it is decreasing and it is negative. So delta G equals delta H minus T delta S. So delta H has what sign? Minus a negative. So what happens when we multiply these two negatives? We get two positives to add, and so delta G is positive, so it is not spontaneous. All right, are we okay with those two questions we'll see on Monday's quiz? Yeah? All right, Monday. We got to do the equilibrium portion of the quiz.
Are we done taking notes?
It is 11:32. I have a little bit we're going to do. I'm debating whether I want to give it or not.
I think we should. We're about to
Miss, what's the benchmark in here?
Miss Lawrence,
Haven't
take
decided.
a break.
It's not tomorrow, I haven't decided.
No, we're just-
All right, we're gonna talk equilibrium.
No.
I'd rather do a worksheet.
I'm sure you would.
I know y'all about to.
But unfortunately, it's not a democracy, so you don't get a vote.
So what is it then, Miss?
It's a dictatorship.
Dictatorship.
Oh, no, we thought we got overthrown the dictator.
Go ahead, let me know how it works out for you. All right, now, we're gonna talk about this equation for just a second. If we had, so it would be really cool if I had this, but I don't. If we had some colorless frozen N2O4, now, just to practice for the benchmark, that's a covalent compound. We can name it either way. Could I get a volunteer to name it using the stock system in Roman numerals?
No.
Does it need a Roman numeral if we name it with the stock system?
Nitrogen 4 nitrogen 4 oxide.
Nitrogen 4 oxide is great. Can I get a volunteer to name it with the prefixes, an old system?
Prefixes?
Was it di?
Dinitrogen tetraoxide. Very good. All right, so suppose we have that at room temperature. It's going to decompose into NO2, okay? Now, based on what you know about equilibrium, equilibrium has to have how many processes? 2. So if it's just going to break down into NO2, can that ever become equilibrium?
No.
No, very good, Simon. It can never become equilibrium if all it's going to do is break down into NO2. What has to happen for that reaction to ever become equilibrium? Okay, so what's going to happen then with that NO2? What's that NO2 have to do? It's got to do what? It's got to change back into what? It's got to change back into N2O4. Okay, so at some point, let's see if I can make that go up a little bit here. All right, at some point, the color has to stop changing, and we have to have a mix of N2O4 and NO2. So how are we going to show that in this reaction? How can we show what's going to happen here and that reaction is going to start to rechange NO2 back into N2O4? We did this back when we studied chemical reactions. I gave you a particular symbol, and I told you down the road, you're going to need this symbol. Does anybody remember what it might have been when we studied chemical reactions?
You talking about?
Some with the arrows,
I triangle.
not a triangle. Yes, it's the what?
2 hours.
That's right. You got to have 2 arrows, and they have to go the opposite way. So when we have this is showing that reaction just changes into the NO2, right? So we have to have another arrow, and it has to go the other way to show that the NO2 becomes the N2O4. Now, I probably have it on the next board, but we need to talk about a forward reaction and a reverse reaction. Let me see what I have on the next board. I probably have that covered because I don't want it. Yeah, I did. I just made it go away.
Like, I don't understand what she's saying until I stop writing. You do that.
Yeah, I can. I was just looking to see what I had. Speaking of
When
that,
I'm writing,
all right, so
I can't.
your homework is just to do what as usual. You choose. Those of you who are behind, take the opportunity to try to catch up. I will be here today after school. This is the last time until after next week. If you need to make up a test, Or quiz. Come get it done. Time is ticking.